Ladies and gentlemen, thank you for coming back with us. We will now proceed to the second keynote speaker presentation that will be delivered by Associate Professor Aini Rakhmawati, Ph.D., and moderated by Dr. Aini Nadir Fatin.
Okay, thank you, MC. So, good morning, ladies and gentlemen. Welcome to the second keynote session of ISICO 2021 with me, Aini Nadir Fatin. So, it's an honor for me to introduce our second keynote speaker, Dr. Aini Rakhmawati. So, let me introduce a brief of her background. Dr. Aini Rakhmawati is currently an associate professor of Information System Department, as well as a vice chair of the Halal Center, Institut Teknologi Sepuluh Nopember, Surabaya, ICIS. And she got her bachelor degree at the Department of Informatics, Institut Teknologi Sepuluh Nopember, Surabaya, and then continued the master degree at the Department of Electronic Engineering, National Taiwan University of Science and Technology, Taipei, Taiwan. And then she pursued the doctoral degree on Insight Center for Data Analytics in Galway, Ireland. Her research interests currently are linked data, big data, semantic web, knowledge graph, and computer ethics. She also got so many awards and honors. Several are the first one is Neo4j Gravy winner for MVP Community 2020, and she also got the Best Paper Award at the International Conference on Halal Innovation in Products and Services in 2018, and also she got the Asian Science Leadership Fellows 2017 as the Best Selected Posters from Asian Young Scientists ASNU 2016, and several many more for the awards. Okay, today, Dr. Aini, she will deliver a very interesting topic in big data, specifically in the graph analytics. And the title presentation will be Knowledge Graph for Food Products. As a glance, a knowledge graph, also known as a semantic network, represents a network of real-world entities, objects, events, situations, or concepts, and also it illustrates the relationship between them. And this information is usually stored in the graph database and visualized as a graph structure, prompting the term knowledge graph. So I believe this topic will really interest you. And Dr. Aini, hello. Okay, yeah.
Hello, Bu Reni.
Thank you.
Assalamualaikum.
Salam. So you have 1 hour to present, and we will have around 30 minutes for the Q&A session. And for the audience, if you have any questions, please drop your questions through the link provided by the committee on your Zoom chat feature. So without further ado, let's hear the presentation from Dr. Aini. And Dr. Aini, the time is yours. Thank you.
Okay, thank you, Reni, as the introduction. So, hello everyone. Assalamualaikum warahmatullahi wabarakatuh. Okay, let me start to share screen. Wait a minute. Okay. Could you see my presentation? Hello? Okay.
Yes, Bu, we can
Excellent.
see.
Excellent.
Okay. Okay, great. I just want to make sure. Okay, before I start to share my knowledge about the food products and so on, and so I would like invite you to this polling. So I drop it in the chat. Okay, so could you please fill out but choose 1 or more topic that you understand. So I give you probably 5 minutes or 3 minutes, and after you choose, there's 2 questions, and this is the second question. So knowledge graph is which part you choose. You can just click mouse which one that you want to go. So I would like to know. Okay, everybody, still one person use machine learning. Okay, nobody know about the food. Okay, maybe now everybody in here still fasting. Okay. Okay, I will wait probably 3 or 5 minutes. And after you finish the first question, just click the left hand, right, yeah. Okay, sorry, this probably right hand side. So please choose which graph that I will talk about. You can guess which one. Okay. Okay, everybody know about the food, right? Okay. I just to make sure that with audience, what kind of the audience topic that you really understand. I hope that my presentation can give you more insight about knowledge graph and food. Okay. Okay, since machine learning, deep learning, food. Okay. Okay. So please also go to another question. The second question, knowledge graph is okay. Some of one person pick the second picture. Okay, most of them pick this picture. Okay, great. Okay, we still have 31 participants. There we have 81 participants in the Zoom. Please just go to this book club ISICO 2021. Okay, I think a lot of people may be hungry, so they choose food. Really? Okay, great. Okay, we still 1 minute left, I think, before I start my presentations. Okay. Okay, more than 60% know about the food, right? Okay. Hopefully, the committee will send or deliver food to your home after this conference. Okay. Okay, I think I stopped the polling today. So this is okay. It's 67 people knows about the food. Of course, we are humans, and also the second popular topic is machine learning and deep learning. So yeah, I saw that yesterday there is a lot of topic about the machine learning, sentiment, deep learning, embedding, and stuff, but only 6% know about the semantic web. But actually, my presentation is more like in 2, 3, 4, 5. But yeah, I will talk about food, but 50% of my presentation is about this part area. And how about the graph? Okay, great. So a lot of people, the majority select the first image. So actually, yeah, I will talk about this graph, not this graph. So why I ask you to choose this part, because I think that many people think that graph is something like bar chart or box plot or something like plotting visualization. But the things that graph in here is part of this one. So I would like have the same perspective about the graph with you all. Okay, now I would like to back to my presentations. Okay, great. So here's the title of my presentation about knowledge graph for the food product. So we will talk about that, and hopefully you're not hungry anymore. Okay, so this is our picture before the pandemic. So we are celebrate the graph day. All of this is the student that's supervised by me but most of them is already, not most of them, all of them is already graduate. So it's 2019. So we celebrate the graph day, and we do a lot of, we have talk about the graph algorithm and stuff, especially for Indonesia. So if you want to join us, maybe later we will have some event for you. We will invite you as well. So this one, okay. What is the graph? So great, most of you know about the graph that I will going to talk. This is about the graph like this. So this graph modelings, for example, that we have Indomie goreng. This one is the nodes, and Indofood also the node, the manufacturer or the company, and we have the edge. Maybe you know this one when you studied about the discrete or about the graph theory, something like that. So, and this one is for the edge, the hash manufacturer. So what we think we talk about is about the relation between the node and the relationship which is have the meanings. Okay. Maybe this is kind of the example that we ever learned before. This is the shorter path, the traveling salesman problem. Could you probably please use the chat if you know about this? Yeah. So this one is the shorter path. How we know which path can be deliver goods or purchasing order, delivery order, something like that. So this is also part of what we talk today. But we not talk about the algorithm about the how we get the shorter path, but mostly in here how we use the data, which is the data still in the graph, and then we analyze that to give a better information and recommendation. Okay. What is knowledge graph? So based on the Aidan Hogan, so this is my friends say that a graph of data intended to accumulate and convey knowledge of the real world. So this one, the real world. Yeah. So this all the nodes is represent the entities of interest, and whose edge represent the relation between these entities. So this is the knowledge graph. And what is the history of the knowledge graph? The first terminology of the knowledge graph is introduced by Edward Snyder in his course, but it's only one occur in his course. The course modulation apply the interface system and its application for the sequence control and data analysis. But in that part, he don't talk about anything about the graph itself. It's just the terminology, how you connect another computer and with another entities. And then in 1980, the Groningen University and Twente create a project called the knowledge graph. But in this time, still they talk about the semantic network. So how we make the semantically and entities between between entities. And then after that, in 2007, there are more people adopt the knowledge graph. This is because there is a two website, two project, which is called DBpedia and Freebase. So DBpedia and Freebase, they have lots of information that converted to the graph. Yeah. And then in 2012, the Google as the popular, I think right now, until now, the popular search engine and application introduced the Google Knowledge Graph. So that's why more company like Airbnb, Bing, Facebook, with Facebook have the Graph Explorer, and also Instagram, and many more. Not only three companies, it's a big company. There's more people use the graph to analyze, to do something like before. I think that like process mining could be used the graph as well for to analyze how is. Iya, adik taruh situ dulu. Iya, buka aja. Okay. So the type of knowledge graph, there is two types. The first is the open knowledge. Yeah, open knowledge graph. The first is the. Iya, adik masker. I'm sorry. Sana dek, mama masih ini. Okay. Type of the knowledge graph. The first is the open knowledge graph. This publishes online. Every people can use that and reuse for the research or for anything. For example, Wikipedia and Wikidata. And the second one is enterprise knowledge graphs. This is private. So, for example, like Google. Google use knowledge graphs privately. I mean, Google never expose what kind of data its data set to us. So he used the web search and also commerce. Commerce, for example, like if you, for example, like web mining, if you after buy these products and you can buy another. This is likely like the graph data. Okay. Okay. So the Google knowledge graph in 2012, they state about the things, not strings. So what does this mean? So this means that for example, if you search the soto ayam, yeah, in here soto ayam, so we get a lot of we can get this one, the right hand soto ayam, with the origin of the food and which the category of food and how it's served and how you cook the food and so on, and also the ingredient as well. So actually this part is Google changed from the strings, which is only the based on the keywords, but it also search by things. So it's how I would like to say, change searching is not entity, not keyword search, but entity search. Okay, so like this, how Google knows that okay, the soto ayam contains that ingredient, how long how it's cooked and how it's served. It's use the schema.org. So it's actually this also adopted by semantic web area. And this one, as you see, is, for example, if you goes to this website, they give a nice example about the banana bread, where this one, if you see, is the description, this one, and also how the preparation time. This one is 15 minutes, and how about the cook time is 1 hour. So they tag or they make tag to every sentence or every things in your HTML page. Yeah. Okay. So and then after that they know that okay, this recipe for the banana bread, what kind of the ingredient, and so on and so on. Okay. Okay, I have two examples from here why they want to use the knowledge graph. So this is the motivation example. So for example, Nur Aini is driving a Jaguar. So if you see if you click right click your mouse and you see the view page source, yeah, use view page source in your browser, you can find like this. Nur Aini and this italic and is driving a bold Jaguar, yeah, something like this. So our browser is only present, like interpret what you see is what you get, yeah, what you see is what you get, something like that. Okay, so actually, what is Nur Aini? Who is Nur Aini? Yeah. What is a Jaguar? This is type of car or animal. So there's a problem because the browser only interpret is the formatting from the italic and the bold to be like this. Yeah. But the browser doesn't know this is Jaguar of type of car or animal. That's why we need a knowledge graph to make it understand the machine, the application can understand when they use, because the browser is for human, not for applications, not for the machine. Okay, so Jaguar is Jaguar is like this. This is the animal. The problem in when you use the keyword search, there is a polysemy and synonym. Like in our, maybe in our language, like bisa for snake, or bisa or for can, or able to, something like that. So because of this problem, we need a knowledge graph to describe what is Jaguar. Okay, Jaguar is entity, entity, and is a car. Car is class. So something like this. So the knowledge graph describe all about the things. For example, like this: Jaguar is entity and car is class. Okay. What is the entity? Entity can be anything. It can be fruit, can be house, or can be balloon, or many things. You are also an entity. We are also entity. Everything in the real world is entity. That we can describe it as a resource. That is entity. Okay. We have the same precision right now about the entity. Right now, as you see, if you search in the Google, in Google Hotel, for example, this is I captured from the, right now Google present the hotel as an entity. Yeah, if you search the Google, for example, near the Jembatan Suramadu Bridge, you can find a lot of Google with the structured data. What is structured data? Structured data is what I say before about this one. This is structured data. So we know that what is 15 minutes, the prep time, something like that. So all of the hotel right now in Google, if you search, is entities, not about the string. So there is a lot of the structured data that already enrich the information about the hotel. Okay. This is for the example how we use the knowledge graph. So this is one of our research, my research with my students in information department, especially in our lab. So we try to analyze the taxonomy of coronavirus. As you see in here, coronavirus has caused in Americas, and I think all around the world. So this actually this coronavirus dataset is crawled by the Magnidam, Magnidam from Neo4j, and then we use that to analyze, use the graph algorithm and also machine learning to predict the link between the coronavirus. As you see in here, coronavirus, they say this for bad, the first one, and then this has caused what, and so on. So, and then after that, based on of this, and then we crawl more data from Wikidata, and then we know that this coronavirus child of another coronavirus. Like for now, we have the Delta variant virus, so that's variant. So that's is really scary right now, right? And so this is our research about the coronavirus comparison. As you see, this is the virus 1 in virus 2, and this the algorithm, the graph algorithm that we use. So this is the common neighbor, pre-attainment, and so on, maximum and minimum triangle count, minimum coefficient. And based on of this, we try to predict the linking between the virus 1 and virus 2. So all the virus we compare one by one, use the graph algorithm. And we can see, like, for example, this one, the Delta virus with this the virus. So they only have the value of pre-attainment 6 and 5. And after we got this comparison, we deliver the result, the feature to the machine learning. We use the random forest. If you're really interested with this result and this research, you can go to the I think this one, our GitHub. So you can go to the GitHub directly. Okay. Okay, so now I will talk about the linked data. So what is the linked data? Linked data is, they call about the web of data. So before, when we know that the first web invented by Tim Berners-Lee, that are web of document, when you click from one document to another document. But right now, because of now the data is entities, so they have a movement to use the data as the entities, so we can link another data with another data, so that web of data. And the linked data, the core of the linked data is semantic web. What is semantic web? Semantic web is mean we change the information to be understandable for the machine. Yeah, for the machine is in the application, and also use the multiple sources. Multiple source is not only one sources, and it's actually it's all about publishing and consuming of the data. Yeah, how your data can be useful for another. Okay, so the semantic web is not just about the putting data on the web. Yeah, on the web, for example, ICICO have the program book you just put on the web, but it's also making links. Like right now in this conference, it's good if we can make a research collaboration. So it's kind of like that. So you can make links for one data set to another data set, so that a person or machine can be, our application can explore. Okay, so if you have that data, for example, like for the coronavirus, we only know, okay, in Indonesia we have Delta virus, we have variant A, B, C, D, but we don't know what is the symptom of this virus. So we can link the data to another data set. Okay, so that is the motivation of the goal of the linked data and semantic web. This is the fourth principle of the linked data. The first is use the URI. So we want to use URI of the name of things. So, and then after that, we use the HTTP URI that people can look up those names. So for example, if you want to look up about the ICICO, so if you use HTTP, people can have the information, or probably like if you have the social media. So the social media username is in HTTP. It's kind of like your identity. And number three is when someone looks up the URI, they provide useful information. They have the standard, use the RDF and Sparkle. Yeah. What is the information? The information is, okay, you have, it's just not you have the, for example, if Indonesia number, maybe number 62, I just say the code area, and then what the information about Indonesia. Indonesia have 17,000 island and so on and so on. There's that a lot of info. And then the fourth principle is include the link to another URI, to another data set. Okay, so not only your data set, so people can have more insightful about your data. Okay, so the linked data technology is about the RDF. I will not going too far, but what is, I think this could be maybe later in another event. And then Sparkle is the query for the query part, and HTTP and URI. Yeah, URI. Okay. Okay, this is the link open data cloud that already we can access this through the website. So I can see you this one. So this is link open data cloud. Yeah, a lot of people, if you see in here, this is the big picture of the link open data cloud, which is we can access the data online. And this is kind of the Wikipedia data. Wikipedia is more general domain. That's why they have the same. And then this one, the cross domain. Yeah, there could be the life science, government, life science, like the virus, gene, drug, something like that, linguistic media, publication, social network, or something. Yeah, so you can go to directly to this site, lotcloud.net. So there you can get that a lot of information, and also you can access the data sets, and then you can play. I think this play, not research. Play is make it fun rather than research. Okay, so there's a lot of data that already link each other in the world. Okay, so the example of the DPpedia, as I said before, DPpedia is the example of the open knowledge graph. This example, if you go to DPpedia Indonesia, you can get a lot of information about the Indonesia. So actually this one, DPpedia extract the information from Wikipedia. So the Wikipedia info box is in the right-hand side. This is the right-hand side of Wikipedia. Extract to this to the link data format, as you see in here. And also, you can also use the Wikidata. I use the Wikidata for the coronavirus as well. In the Wikidata, we can get a lot of information. For example, it's also in Indonesia. But what is different between the DPpedia and Wikidata? Wikidata is also part of the Wikipedia, but in the Wikidata, we can the people also can edit, can contribute. Yeah, not only generate directly from the Wikipedia, but every people can collaborate to edit the information in Wikidata. Okay, so we can use that for our research, especially in graph. And now, probably, Bu Reni, probably any questions so far before I jump to the link pendeta halal?
Okay, Dr. Aini, perhaps the Q&A after you finish your presentation. Yeah, I think you can continue for the video if you want to show. You are still good? I'm sorry.
Okay.
Okay.
Sorry. Okay, I will share again my. Okay, now I will talk about my research, my current research. I think it's still 5 years. So about the link open data halal. So because right now I also be the vice chair of the Halal Center of ICIS. So mostly my research is about the halal, but I think what I talk in here is also about the general food. It's not only a halal. You can use the algorithm also for the general product, not only a halal food. Okay. Oops. Okay. So link open data halal we started in 2015 until now. We still research about the halal product, and we collect the halal certified product from around the world. So right now, from 200 the organization certification halal, it's only 7 only 7 certified products that already provide the data. So what does mean in English? Yeah, in English, because it's difficult for us in Arabic or in another language, and also they accessible to us to crawl the data, to collect the data, and most of them mostly in PDF, and then we convert that in the machine readable data to RDF and link data. And then we also propose the halal food vocabulary for that, because we think that halal means that we need the certificate also from the organization. It's not only you just that, okay, this halal it is not halal, something like that. So we need the organization certification, and more data set right now. Not only this one, we also combine with another data set, and we do something different for our research, and also we provide the search engine, API and the mobile apps, and also we do like data integration with another data set. Okay, for example, that data set that we use, the Open Food Fact. Open Food Fact is, and I think right now is more than 500,000 products. So this is the crowdsourcing product. If you use the data, this data is this open database license, and you can crawl the data. I think that in CSV formats, but the data is really dirty. So that's why we need the pre-process to clean the data before we use in our research. And also, this is the architecture of our current system. So we have the website, we link that with DBpedia, like I said before, the link data, that we also use the MES. MES is for the medical data set, because we think that we want to know about the ingredient, this ingredient, especially for the additive ingredient. This is what is it all about, how is the medication, something like that, the side effect of the ingredient is also with PubMed as well. Yeah, so because it's difficult for us, I mean, we only clone the data about the ingredients, but we want to know more about the information about the ingredients. So we link that with the DBpedia and MES and PubMed. And also we use the halal certificate from our Majelis Ulama Indonesia, and then e-number, because there is a lot of e-number and Open Food Fact. And right now we also add more and more data sets. We use this web searching with entity search and halal prediction with the indexing by USIN. Okay, so this is the vocabulary. Vocabulary is mean for you, probably you know about the database. Is kind of the ERD, the entity relationship diagram. So this is a link open data halal vocabulary. So we know that we have the halal ingredient subclass of with halal food additive and halal food product, and in this vocabulary we use the popular vocabulary, which is called the food TRM, and we use the FOAF as well, and also the food vocabulary. So we not not create by ourselves, but we expand from the popular vocabulary. Why? Because if maybe people use our data set, they know that they already can just add something information for the halal status, because they are in halal status. We follow the nano publication, which means we have to know which the origin of the certification, something like that. So this is our vocabulary. Okay, then the example of our data set, but it's part, actually there's more and more. And this, for example, Burger King certificate by this one with Emirates Authority for Standard and Metrology. This is from DBI United Arab Emirates. This is the DBpedia dataset. So this, our dataset is only this. And this another dataset, our dataset about from the Majelis Ulama Indonesia. Burger King Indonesia already have certificate halal, and this is origin from the Majelis Ulama Indonesia from Indonesia. This is so if there people know what which country about from origin, the Majelis Ulama Indonesia is from Indonesia. So this kind of like this. So we can link all the data set to the DBpedia as well. As also ingredients, we also link with the DBpedia as well. And manufacturer, the company, we link that with DBpedia. Okay, this is the example of Happy Toast, rasa jagung bakar. I love this snack. Yeah, so this is Happy Toast rasa jagung bakar. So this is how is we change from the data from the the text data to the RDF or the link data, something like this, where I'm code this and contains ingredient this, workron and pearl and so on. This is the energy. I mean this is the nutritions, and then the certificate is from Halal Mui. I think that's cut in here. We crop it. This is all the ingredient. So this one is starts halal and so on. So this is the code. The data set before from the strings, the text to link data format. Okay. So how we do the prediction in the food product, especially. But actually, what we do currently we use the halal product. But I think that's also applies to another food product. But we use the graph embedding in here. We use the graph algorithms and then machine learning and deep learning for prediction and also for entity resolution and for data integrations. Okay, what is the graph embedding? As you know that maybe you still recall about the matrix, matrix. So graph response usually is modeled by matrix. If you have relation, the value could be 1. If you don't have a relation, it's 0, something like that. But the problem is it's too high. If you only 5 nodes, 5 nodes is okay. You have n times n, so that is okay. But how about if you have a lot of nodes in your research? For example, for me, I have kind of 500 products. So how we deal with this situation? So that's why we use the graph embedding to make our data set is low dimensional representation for the graph. And also this is also good if you use this input or these features to machine learning or deep learning. So that's why we change for this graph. We use the sampling strategy, and then after that we just skip graph model. It's usually like the word to fact, something like that. Word to fact and anything fact, to word to fact, not to fact, to fact. There's a lot of fact, and then we use this embedding. So from graph, the nodes that similar each other will be grouped in one area. It's kind of like the clustering, actually, semi-supervised clustering. Okay, this is the motivation why we need the graph embedding. The first, maybe this not to fact. That's the popular graph embedding right now. This learns the low dimensional representation for the nodes by optimization the neighborhood for presenting the object. So the not to fact use the 2 strategy, the breadth first sampling and the depth first sampling. I will not talk about more about the algorithm. So this is how it looks like. So from the breadth first search to predict the local neighborhood, but from the depth first, the blue one, this will look at the whole of the global node. So we not only think about our local neighborhood, but also the local neighborhood. So that is the idea of the not to fact. Okay, so we try to embedding to visualize our data set to the not to fact. As you see in here, it's kind of like dot everywhere. So mostly is because Majelis Ulama Indonesia is the majority in our data set rather than the other data set, because it's easy to cross, as you see in here. And then I'm sorry, I have to drink. And also another Muslim customer groups that located itself, and also the South Africa National Health Authority in here. But just a bit dot in somewhere, but mostly in here, in the center of the graph. Okay. Next is, I think the center. Okay. So this is the visualization of our not to fact. So as you see in here, nisin wafer cream, rasa pisang, coklat, vanilla, strawberry, has the same have connection with another, even the another data set maybe doesn't have the same, that it doesn't have ingredient, but that has the manufacturer. So this is, we can see the relationship about all the nisin wafer products, so that are in the same. Okay, and then we do some linked entities, use the OLSMS and also RDFC also. So the OLSMS is if the product is the same entity, but RDFC also form the related entity. So for example, Indonesia in the Wikidata Indonesia and DBpedia Indonesia is the same entity. We can use the OLSMS link. But for Indonesia, Surabaya can see also Indonesia because it's related entity, something like that. So the example, okay. And in also how we create the RDFC also and OLSMS, as you see in here, nisin wafer cream vanilla susu is same as with the chocolate. Probably, well, it's different, but it's different. But I think in here, because we use the similarity, the similarity of the ingredient and also about the name as well. So the name of the food product. So they say that based on the machine, they say this link use the OLSMS. But for the another, as you see in here, nisin wafer with the biscuit kering is RDFC also, because it's not wafer. This is biscuit, something like that. So this is how we link our data set. Okay. And this also the visualization. As you see in here, this is the MUI, the ingredient, and the certificate, and this Torabika, the manufacturer of Torabika, so they, because of this relation, so the Energen has also relation with the Torabika Eka Semesta, the manufacturer is the similar, actually this similar manufacturer, but because this the PT is in the end and this is the beginning, so that's why we can say this all same as each other. So this based on our prediction result. Okay, so and also we in other research we also use the RDF2FACT, because some people argue that not2FACT is more heterogeneous data, which is these different sources, and also we try use RDF2FACT as well in our research. As you see in here, zona telur gabus, sweet cookies has similar with the zona kemplang ikan, this kind of the snack as well, kemplang ikan of crackers, fish cracker, and so on. You can see how we create the prediction between the products. Okay, and also besides use the graph embedding, we also use the graph algorithm itself. There is a lot of graph algorithm that we can use. For example, PageRank, that is popular in with the Google ranking algorithm. Node similarity, Jakarta similarity, Corsin similarity, percent similarity, equivalent distance, overlap distance, Adamic Adar, and many things. There's a lot of graph algorithm that we can use directly if you don't want to use like the graph embedding actually. But there is probably there is a pros and cons as well in this. Okay, and also in the recently we also crawl the data from the Klik Indomaret, the popular retailers in Indonesia, and also from the Halal MUI again, but because the Halal MUI always renew the certificate every 2 years, every 2 years. So that's why we crawl more data from the Halal MUI, and then we integrate the data with the link open data halal that we have. Okay, So this one, for example, we use the graph algorithm in here. We use the Jakarta, this one, Jakarta algorithms, Jakarta symmetry algorithm. So we can get the Kitela, or the Kitela kripe, yeah, Kitela cracker. This is cassava cracker, and then with all of them is similar with the Jakarta because of this one. The similarity is more than 4. Actually, we can use more. It depends on the threshold. Yeah, so we can make the visualization between the Kitela and this one. This is the certificate. So not all the products that we pull from Indomaret is halal, have halal certificate. So this is the information. So because this Kitela has the the halal certificate, and this is have the similarity with another Kitela products. So this is the result. And also we use the PageRank to visualize our data set. For example, the Selamat wafer in here have the big note, big size, because of the PageRank is 2.43. That's why it's the big size of one. The PageRank is calculated from the outgoing and ingoing link in this. Okay, next. Okay, this also the recently of our research. When we already have collected the data from the link open data halal, the previous data set, we integrate that the click Indomaret data set, and we use the graph embedding, like not to fact, RDF to fact. After that, we train the data set, use the random forest and a lot of several machine learning, and we train the model to predict the link between of the products. Yeah, so this is the result. The result of the ROC. So the random forest is the highest in here, the highest ROC, and naive bias, logistic, and so on. So this is the result of our embeddings from not to fact, RDF to fact. We use this one for the ROC and AMCIS when use several algorithm. And for the final, you can also go to this link. So I can give you this one. When we use the not to fact, not to fact, and then random forest, we get this one. So you can go to the link. This one, the visualization not to fact hierarchy apps. So you can see the link. All the halal, especially this one is only for Indomaret dataset, because if I use a lot of dataset, it will be cannot see clearly in here. So you can see for example, this the milk Frisian flag, yeah, and this one is the wafer chocolate, and so on. So this one, so you can see the relationship between the product in Indomaret. Okay. Sorry, I'm not sponsored by Indomaret, but I think that if we can see, because Indomaret, we use usually right now buy anything from Indomaret, so you can see which relationship the product in Indomaret. And also this one, if we use the RDF to fact, so the RDF to fact, the performance is not really good in terms of link between the product, as you see in here, not really crowded rather than not to fact. And also, Emma, the result, I mean the link, but we can get a few results from the RDF to fact. Okay, this one. See, oops, you can make it clearly like this. Oh, sorry. Yeah. Sedap mie instan. So I think this one, the idea, you can also like have the food recommendation. If in Indomaret doesn't have sedap mie instan, so you can choose the Indomie mie instan. Oh, okay, this obviously the same the same mie instan, noodle instan. So you can I think this one can be choose another noodles. Okay. Okay. I think that Alhamdulillah. Thank you. So I set myself a mother of two notes, yeah, and also halal lifestyle coder and advocate. So please, Pak Niswu, can you play my video about the how? Yeah, okay. I think I cannot hear the voice. I think no voice, Pak Niswu. I cannot. Okay,
There
great.
is still no sound.
Okay, so that is the idea behind of this. Okay, so and last year we used the Python for this, and luckily this year we found that Neo4j already support the graph data science library. So and then we also look at the neo-semantic library from Neo4j. So and then we think that we can use the Neo4j for help us solution. So first we import the halal dataset from our website. So you can go there. This is public dataset, it's free. So please use that. And also we create a new graph, and then we calculate the similarity score. And then we add new similar property. And then after that, we label uncertified product, use the new property. So this is the idea. So, okay. So how we import the RDF halal product? So the first thing, you need to install the neo-semantics, yeah, and then you can use this with constraint and blah blah blah. You can use this one if you, and then after that you need to init for the graph, and after that you have to fetch the TTL. So we already provide in our website in this. So I use this because I already download in the local, and then you can also directly go to this link. So this is I already provide in there. Okay, after that we already get the similar property that I already told you before. Now we can compare between the halal certified product and non-halal certified product. So we can use the cheaper query in the Neo4j. So what we do in here like this. So we have this one, the halal. So this one, the match here. If you see in here, the product one doesn't have halal certificate. Yeah, and product 2 have the halal certificate. As you see in here, have halal certificate. And how we know that the P1 or product 1 doesn't have halal certificate? Because we use the optional match, and then we say that if it's in here, the certificate is null, and then after that we add more in here. If the score of the similar score that we already assigned before, if above 90%, so we can say that we set the new property for the halal, the new property, we set say assign 1 for the value is 1. So we can say that if we find the new product which is have the halal equals to 1, so we can say that it could be this product is halal, but we can make sure that 100%, but we can say it's 90% is halal. So, and then we can run that, and this is, if we run the query, and we get this one. So this is the result. Oh, sorry. Wait a minute. This is the result. The result is this one. Wait. Okay, so we can see that this product one, the La Fonte is kind of pasta, have the similar ingredient with Singapura Premium Ginger, which is the La Fonte has the ingredients and also have the halal products. And the Singapura doesn't have the halal certificate, but the ingredient between this product is the same. So we have the set, the property, the new property value halal is 1. So we can say that is halal. So, and then we have sarimi. Sarimi doesn't have the halal certificate. Sarimi is the noodles, the popular noodle in Indonesia, have the similar ingredient with the Indomie, mie rasa ayam bawang. So we can say that this also halal. So sarimi, maybe 90% we can say this halal. Or you can also change if you not make sure, no, I don't want this 90%, but probably it's 90%, then the last ingredient is the pork, so we cannot say it's halal. So you can change this score to be not 90%, but we can change this should be the 1. So it's just okay. So it's depend on how is your data set looks like, but I think that 1% or 95% that could be better, but not 10%. Okay, so this is how Neo4j can help us to detect the algorithms. I think next I think we can create a more data, and also we also can compare with another graph algorithms in Neo4j, for example, Jakar or Cosine similarity equation and anything else. So that's how this goes. And thank you so much. So hopefully you can understand what is the halal and how you can use the Neo4j for detect the halal status of your product. Thank you. If you have any questions, please let me know.
Okay, I think that's all from my presentation. I will return to Bu Reni.
Okay, well, what a wonderful performance, Dr. Aini. And thank you so much for your excellent presentations. So let's continue to the Q&A sessions. Please allow me to check whether there are questions. Okay, so we already have one question here from Mr. Hatma Suryo Trisongko from Kumamoto University. You explained graph plus ML for COVID-19, I have 3 questions. So the first one is, what is the purpose of combining graph theory with machine learning or deep learning? And the second one, does graph theory offer benefits for MLDL, such as improving performance or accuracy? And the last one is, what is the research direction for graph theory to advance ML and DL for cybersecurity research and applications? So Dr. Aini, please respond to this question. Thank you.
Okay, I think Pak Hatma is the super cool and popular participants right now. So thank you, Pak Hatma from Kumamoto University. Okay, what is the purpose of the combining graph theory and the machine learning? As I say in the, I think that's in the middle of the slide. So the graph in here not is the graph theory. Actually, the graph algorithms. I have the taxonomy of the COVID-19 about the relation between this virus is host of or child of another virus. So that's why I try to I try to collect more information in the graph format, and then I predict the the neighborhood between of them, and also try to analyze the information between of that. And this calculation can be the features of the machine learning and deep learning. So the purpose, this one, I would like to see the prediction, the link prediction between the one virus to another virus. Okay, and for the second question is, offer benefit the machine learning and deep learning? Yes, it is, because if we only use the one algorithm, for example, if we use only Jakarta, would be we only know the common neighborhood. But if we also add more graph algorithm, for example, like PageRank algorithm or pre-attain algorithm or triangle count or Loven for prediction, or we can have better more and more features. But also we not only just jump it to the machine learning or deep learning, we also try to analyze with the feature that really be the main component for, the more significant, the significant feature for the input for the machine learning or deep learning. And for the third question, it's really great question actually in the cybersecurity, which is I never used before. But actually, there is a lot of research in the cybersecurity, use the graph, the knowledge graph. For example, about the terrorist attack, or like for in the online SNA, social network analysis. So we know that probably if you use the prostitution, something like that, we know that this person is, I have that kind of the research. So we know that this person is the same. The same, but they have the same person, but they have many accounts published in the social media, but actually it's one person, something like that. So I use the graph as well, the graph algorithm to predict this one. And also for, I think there's a lot of kind of research that we can use the graph as well, because we can see the relationship between of the entities that have a problem or attack this our cybersecurity. Okay, that's probably my answer. Hopefully, Pak Hatma. Okay, thank you, Pak Hatma.
Okay, thank you, Mr. Hatma. Thank you also, Dr. Aini. Perhaps we have another questions from the committee. Okay, we have another question from Fahitah Rizwan from University Science Malaysia. So how to tackle the issue of data quality in linked data?
Okay, that's great. Very great questions. Yeah. So yeah, until right now we have a lot of problem in the linked data. So now there is a movement to the linked data evangelists or linked data people to follow the fair data principle when they consume and publish the linked data. So also they also have the, I think have the, they also have to follow the nano publication as well when they publish the data, because there's a problem, for example, like the data quality in terms of the provenance of the data itself, and also how if the data can be, there's a lot of noise, something like, what they say, some typos or something. So they also have SHCL for what is the for for the check, is the data, is your link data is already proven. I mean, kind of like make sure your link data is can be follow the vocabulary of your link data dataset, something like that. Hopefully can answer, or if there is any, feedback from the participant, from Ibu Fahita,
Yeah.
this one maybe.
Yeah,
Or we
Ibu
can
Fahita.
collaborate later. It is a collaboration.
Okay, well, Ibu Fahita, do you have any feedback or following question?
Yes. Can you hear me?
Yeah.
Okay. So
Wonderful.
good afternoon. Good afternoon, everyone.
Yeah.
So my name is Bahita. From Aini can just call me Ita. Okay. So
Okay.
actually, because my research is focusing more on data quality and data cleansing. So when I look, when I go through the sharing today, I thought that clean data can be used as one of the source for data cleansing. But what the concern is, what about the data quality? Because data quality and data cleansing is my expertise, especially we are dealing with big data. So yeah, linked data can be used for data cleansing, but the concern is on the data quality itself, because we gather all the data from the does it from the open source, or how does it being collected, the linked data?
Okay. Thank you so much. So that's great. Like what I said before, if you see the link open data cloud that I already present about the website, so they already probably can I oops. Okay, I could not share my. Okay, that's okay. The link open data cloud. So in the link and open data cloud, every people can. It's kind of like crowdsourcing. There's a lot of the issue, especially when I work in the big data AU. For example, like in the Amazon and BioRDF. BioRDF is kind of the life science data set. They also use the people to make sure the quality of the data is still human evaluator as well in there. But they also use the link data. For example, for the entity resolution is to make sure that your data set is not redundant, right? So this one, you can use the link data as well for that. But for the data quality, they also provide the data provenance and also use the some algorithm, like what I said, that the graph similarity, something not similarity, to make sure that there is no redundant data set, and also to clean up the data set as well. So that is what I found so far in based on my experience. Yeah.
Thank you, Doctor.
Okay. Oh, okay. Thank you, Ibu Fahita and Dr. Aini. So let's see whether, okay, there is another question from Bu Chut Al Nafadila from NTUSD Taiwan. May I have to know the rate of unique findings that have encountered, and what's the government side impact by doing this halal project? It's more related into the implementation area.
Okay. So it's concerned on halal, right?
Yeah.
So the unique thing about the halal, yeah, because until right now, it's still difficult to find the halal data set as well. So like what I say, in 200 or certificate organizations in the world, is only 7 that already provide the data in the open data, but also in the PDF, that is still difficult for us to change from the data from PDF or from the web to the RDF. So that is the problem. And also, this is the behind the secret. So it's difficult for us, the Jakim in Malaysia, also in MUI Indonesia, they do not have the data in the open data, or probably in higher things in the link open data. Most of them share the data only in the web. So just, okay, this is published on the web, and we have to have the strategy for crawling the data itself. So this is the things that we are encounter so far for the data itself. So from the halal project, things is beside of it's difficult to find the data, and also in every country has different policy about, I mean, different policy to just this can be labeled as halal or haram. Because, like, for example, in Japan, probably you can ask Pak Hatma, in there they only check the end product. So in the end product, if doesn't contain pork or wine or something not permission by Sharia, so it say that it's halal. But in Indonesia, we use the traceability product. So from the beginning until when it delivered to the end user or consumer, it should be not mixed between the halal and haram. So that's why the unique things about doing the research halal is something like that. So every government or not government actually, we could say mazhab, maybe, mazhab from Hanafi and Salafi has different direction to say that this product is halal or not, something like that. Yeah. Okay.
Okay, thank you, Dr. Aini. Does it satisfy your questions, Ibu Chut Alna? Or you have? Oh, okay. Thank you. Any more questions? Wow. Okay.
Okay.
Perhaps. Pak Adam, do you want to ask directly to our?
I don't think so.
Okay, there is one question from Pak Adam Akbar from ICIS. So the first one is, which case are highly recommended to using knowledge graph? And the second one is knowledge graph rather than table-based TDMS, for example, MySQL.
Okay, that's great. That could be the question about between the no SQL and SQL person. I mean, it's kind of political things. So when we use the knowledge graph, so okay, that's not all the case can be solved with the graph. Yeah. So you have to check if your data set there is a lot of relation or not. For example, like what I say about the clickable between one document to another document for the visitor of your website. That could be it should be in the graph. Or for social network, so you follow another account in your media social for another account. So this could be use the graph. And as well in our case in coronavirus is also because it's taxonomy, you can use the graph. So I don't say that if it's a transaction database, for example, like if you have order, like order from the bank transaction, I think that we cannot use the graph for your data set. So it's depend on your case. Is knowledge graph is better than? I don't think so as well. So it's depend of your case. So choose the technology. I say the technology or the algorithm is depend on your case. It's not always the DPMS is always better than knowledge graph. So I think that in our lab we also have different polls between the no SQL and SQL persons. Okay, thank you so much, Pak Adam, for the questions.
Okay. Thank you, thank you, Dr. Aini and Pak Adam. Or Pak Adam, you have feedback? Oh, enough. Thank you. Perhaps we have another question, maybe for the last. Oh, okay. So this is, I think this is the last questions from Mr. Haikal Akhtar Nugroho from ITS. So when living abroad, the halal status of product might be harder to determine since there are no strong force for producer to ascertain this halal status. So therefore, it is obvious how study halalness using knowledge graph might be useful. So what are your thoughts about implementing the same thing in Indonesia, since we already have bodies such as the MUI and BPOM working on the halal status of the products?
Okay, great. Pak Haikal or Mr. Haikal, thank you for the good questions. Actually, I would like to make some correction in here. It's not BPOM, right? This is because BPJPH. So BPOM is for check your product is about the healthy. Yeah, BPOM is for the healthiness, not about the halalness. Yeah, we have, as I say in here, in Indonesia, we have MUI, Majelis Ulama Councils in Indonesia, but the problem is, as I say in here, is only 20% of our products is certified halal. So for us, knowledge grab can make some recommendations. So if you not have another products, the halal product, you can have another recommendations for another. I mean, like substitutions. But I say that okay, in Indonesia have different policy how to predict your product is halal or not, because we have the policy that the regulation is not only about the ingredients, it's not about the how use pork or not, but all of the process from the beginning when you choose the ingredient until this product sent to the customer, something like that. So I think this obviously, yeah, you say that we cannot only use the knowledge graph, but this knowledge graph is only for recommendation. For if you don't have the halal product, you can choose the substitution of another product. But again, it depends on how is the religion. I mean, because there is a lot of mazhab in Indonesia as well. Yeah, maybe Hanafi, Shafi'i, or something like that. Okay, that's all my answer. Thank you so much for your concern, Pak Haikal.
Okay, thank you very much, Dr. Aini and Pak Haikal. So I apologize that we couldn't continue for the Q&A since the very limited time we have. And to sum up this session of keynote speaker, perhaps I want to tell about the topic that presented by Dr. Aini are including the history of the knowledge graph, the type of the knowledge graph, and so many applications that already use this method, such as Airbnb, Facebook, web commerce, e-commerce. And the last one, she also presented about the application of this method in the halal food products, especially in the halal food information system. Once again, thank you so much, Dr. Aini. And I believe that the committee already prepared for a certificate, right? A certificate for the keynote speaker. Yeah, the committee, would you like to share the certificate for our keynote speaker, Dr. Nur Aini Rakhmawati, to thank for her very great contribution as our keynote speaker in this conference? Okay, so Dr. Aini, this is for you. Thank you very much for the great contribution at this keynote session. And hopefully it will be your proud in the future.
Thank you so much for the committee, especially for Pak Izzat and also Pureni as the moderator. Thank you so much. So this could be the one of my history in ISICO after.
But you did a great job, Dr. Aini.
Thank
Okay,
you.
thank you once again. So before I end this second keynote session, so I would like to invite all of the participants here to turn on the camera, as we will have a virtual photo session together. And I believe that the committee will help to give the instructions. So please, everyone, turn on your camera.
Yeah. Okay, the photo session will be done by Pak Faisal Johan.
Okay.
Pak Faisal Johan. Sorry, I'm using another person's laptop here, so I don't know. I'm not really sure about the screen. Pak Faisal Johan.
Okay, Pak Faisal, you there?
Okay, I will take a picture.
Okay.
One,
to
2, 3.
Okay.
Okay, next page. 1, 2, 3. The last page. 1, 2, 3. Okay, finish.
Okay, thank you again for the committee. And once again, thank you for all your great participation here. And I will return this session to Jihan as the Master of Ceremony. And everyone, please enjoy the rest of the conference. Thank you from me, Feni Fatin. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon.